Yeah, you still.
Right, yesterday we looked at graphing of equations and finding the solutions using the intersections. And today we're going to solve these equations exactly the same way and using algebra, and then we will check the solutions using your graphing calculator. So no matter what, you can use your graphing calculator to make sure you've got the correct solution. So the first example, and again, this goes back to what we have already done this year. Okay, so there was two methods, and we did this in applied where we did it with lines. So there's two methods. Number one was substitution, number two is elimination. Okay, so we'll start with substitution. Substitution just means that you isolate one variable and then substitute in the other equation into, in the isolated variables equation into the other equation. Well, in this case, we have y equals in both cases. So we will substitute in that in for that y right there. Oops. Okay, so we have it substituted in, move it all to one side, simplify it, and then you have to find your x and your y, which your coordinates are where they meet. So what are the possibilities of outcomes here? I have a line and I have a parabola. How many outcomes are possible? Two, 0, or 1 if they just touch, right? So let's find out. Move that over, move that over. Okay, so I have it equal to 0. We know of 4 methods in order to solve this. The first is factor, of course. That's the one we want to use. We have the quadratic equation. We have graphing. And it is completing the square, but we'll never use completing the square in this course for this particular question. So, can this be factored? Yeah. X, -3, x plus 1 equals 0. X is equal to 3 minus 1. And then we have to find out what the actual coordinates are. So, y is equal to 3 subtract 3. 0, so my first coordinate is 3 and 0, right? And my second coordinate is -1 and -4. So it crosses at 2 coordinates. Then I would graph it, just to make sure. Okay? So that's substitution method. That's probably the method you're going to use the most frequent, because most of the questions are giving to you as y equals, or you just have to simplify it to get it to y equals, and then just make sure that you equal both equations after that. Okay? The second method, like I said, is to use elimination. So elimination works by lining up your variables and then subtracting to get rid of the one variable you need. Again, when we did this with lines, we would either get rid of the x or the y. Here, you're almost entirely going to try and just get rid of the y. So the second equation, I place it below, but when I place it below this time, I'm going to line up my variables and my constants together. So I'm going to put them underneath each other like that. Okay? Now to get rid of the y variable, what am I going to do with the two equations?
Second one. Multiply by -1.
Sure. Multiply by -1 and then add it. Okay, yeah, I like that idea. To me, that's the best. So I'm going to multiply by -1. And then I'm going to add these two together. So that gives me 0 equals x squared minus 2x minus 3. And then the beauty of this, and I said this before, the beauty of it is you do the same thing now. No matter what method you use, you do the same thing. Factor, solve. So again, you would get x is equal to 3 and -1. And then So now I do the same procedure right here. Substitute in, end up with your same answers. Okay? So those are the two methods that we're going to do. So let's look at the first example on 347. Oh, no. No. All right. Sorry. That's around here. Okay. First equation: x squared minus x minus y equals 6. Second equation: 2x minus y equals 2. All right. So it's up to you. Whatever method you want to use. Okay. Looking at it right now, the simplest method for this would be elimination, because all I have to do is then multiply by -1 and then add them. Okay, so I would line this up a little bit better. So I have 2x minus y is equal to 2, correct?
Mhm.
So then let's multiply by -1. Add those two together. X squared minus 3x equals 4. Right? So I'm using the elimination. You could eliminate y by multiplying by -1 from 2, or subtracting 2 from 1 is what it says in the book. You would end up with a quadratic equation with the only variable. So now I go x squared minus 3x minus 4 equals 0.
-4 and 1.
-4 plus 1. So x is equal to 4 -1. So if x is 4, put it into that second equation there. So x is 4, that gives me 8. So what is it? We go into 6, right? Okay, and -1 and
It should be -4, shouldn't it? +1. Because if it's become -3.
what makes that equal 0?
Oh yeah, sorry. Okay. Oh yeah.
You good?
Yeah, I was just
Actually,
thinking.
you're talking about that.
Yeah, that's what I was talking
No, but you want -4.
Yeah.
Okay. So -1. So 2 times -1 is -2. Add it, that gives me 4. Y equals -4. Okay. Issues with that? Okay, well, let's look at a little more difficult one. Not more difficult, just more work. Let's look at this one on page 348. Again, line it up. If you want elimination, line it up when you write it out the first time. Saves you time. If you want y equals, change it to y equals right away. So this time, last time I did elimination, this time I'll do substitution. So in that first equation on page 348, I'm going to get y is equal to 3x squared minus 24x plus 52. 3x squared minus 24x plus 52. That's the first equation. Okay, so I moved y to the right and moved 52 back to the left. Fair enough? Second equation, y is equal to minus 2x squared plus 16x minus 28. Okay, so now I'm actually set up nicely again for elimination. So that's what you wanted. But we'll work with substitution, because so I've got 3x squared minus 24x plus 52 equals minus 2x squared plus 16x minus 28. Oh, bless you. So now, tricks of the trade here. You can do it whatever way you want, but my preference is to always make that x squared positive. So to make x squared positive, what am I going to move?
Minus 2x.
Minus 2x squared, right? So I'm going to add that to this side. That gives me 5x squared. Now I'm going to move that, so let's subtract minus 40x, good. Add that, 80, right? Okay, so now what? Divided by 5, great, greatest common factor, well done girls. X squared minus 8x plus, is that 16? 14, 16, 16, right? 30, yeah. Okay, factors?
4 and 4.
That's right, very good. X is equal to 4. So what does that tell us about those two quadratics? One solution, and where is it? It's on the vertex, right. So let's find out what the y value of the vertex is. So I've got 4. Okay, do this mental math. 4 squared is 16. 16 times 3 is
48.
48. 24 times 4 is
96.
96. So 48 subtract 96 is
Negative 48.
negative 48. Add 52 is beauty. Well done. Okay? 4 and 4. There's your answer. What's the vertex for both of those? 4 and 4. Again, you can check it by graph. Okay, so far? Alright, so again, not new to you. Not new. The only thing that's new is we end up factoring here. What happens if I cannot factor?
Use a big long equation.
Yeah, I wouldn't. I'd just graph it then.
Oh.
Even at that, like if I got to this point here, I would just graph that. Okay? Don't use the quadratic equation unless you really have to. You've got the calculator, make it work for you. Now in theory, you could have done it up here too, right? You could have drawn both of those and then found out where they meet. Okay? But if it's asked for, and it'll be specified, you need to algebraically do this. So you get it to right here, and then at that point, graph it. Okay, but you gotta show your work. Alright? Okay, now finally the word problems. So this is, although this isn't gonna be, they give you the equation, so that's not really, I don't need to go through that. Two golfers are practicing their swing at the driving range. Each hits the ball at the same time. The path of the first ball can be modeled by the equation y plus 27 equals negative 5x squared plus 40x. The path of the second ball can be modeled by y plus 8x squared equals 40x. Each equation, y is the height above ground and x is seconds. Determine and interpret the solution of the system of the equations. Okay, so you write each one as y equals, eliminate y, solve the resultant for x. Use your value for x to determine the corresponding value for y. State your answer. What does the solution mean in context of this question? What do you think is happening here? That's the only part I really care about because the rest is already done. What does the solution mean in the context of the question? What's happened here?
Two golfers hit the ball.
Two golfers hit the ball at the same time, and what's going to happen?
At one point, they're going to be the same height.
At one point, they're going to be the same height. So they meet. So they both apex at the same point. That's what that means. So you have two golfers. One's going up high this way, you know, and then the other one kind of gradually gets up, and then we'll hit the same point there. Okay, that's what's happening. So again, that point right there is probably where they're going to meet. Now I don't know how it looks, but that's what it means. That's the context of the question. Okay, so in that question they give you the equations. So you just have to solve it using one of your two methods and then check with your calculator. Okay? How did we make out yesterday? Slowly, Callie. Sure.
Off.
Wow. It's been half the class talking.
I spent half the class listening actually. And then me and Trin got into a fight because she was wrong.
I was not wrong. There's a continuing
Oh, there's an argument for a week.
It will be
Who was
actually.
right and who was wrong? Okay, did you have any trouble with the questions yesterday?
Tried some locality.
No?
What?
It was just graphing, correct? Hey, you two, stop squabbling. Nothing we need to go through today? Okay, got the rest of today to work on 8.2 then.
There's only two.
Yeah, it's only 8.1.
Is there only eight,
Yeah.
one or 8.2?
It's really short.
Beauty. We'll test on it then, that means it's an easy test.
What?
It's only 8.1 and 8.2.
So we-
Tomorrow.
Test by the middle of next week, yeah.
This is it?
Yeah.
8.1, 8.2, yeah. So we'll test